Hello students, so today in this video we shall try to understand what are the oxidation and reduction processes in chemistry. So oxidation and reduction are one of the important types of chemical reactions, and these are the very basic concepts of chemistry which every student should know. So let's start. I will explain oxidation and reduction processes definition, and I will also explain what are the difference between these two processes. So let's make a table, and on the left side I will write the characteristics of oxidation process, and on the right side I will write the characteristics of the reduction process. So let's write. Oxidation, as its name suggests, oxidation is classically defined as the process of addition of oxygen, and contrary to this, reduction is defined as the process of addition of hydrogen or removal of oxygen. So let's write this. Oxidation is the process of addition of oxygen, and reduction is the process of addition of hydrogen. This is the conventional definition. In another way, we can define oxidation as the removal of hydrogen, and reduction can be defined as the removal of oxygen. These are the conventional definitions which we used to use in older days, but this is true, not false, and there are some more characteristics. Let's add them also. So oxidation can also be defined as the removal of electrons, and contrary to this, reduction is the process of addition of electrons. Next, oxidation is the process of increase of positive valency or decrease of negative valency. Decrease of negative valency means negative valency will shift towards zero, so it will become smaller in magnitude. And similarly, for reduction, we can define as the reduction is the process where there is a decrease in positive valency or increase of negative valency. Okay, and next definition we can write. Oxidation is the process where oxidation number increases. In the same way, in reduction, oxidation number decreases. Okay, so these are the main points which you should always remember about oxidation and reduction processes. So let's understand each of these points by some examples. So oxygen addition, the definition of oxidation, the first point is addition of oxygen. So an example of this, suppose we have sodium 2Na and it reacts with oxygen, so oxygen is getting added to it. So what it will form? It will form Na2O. So I should write, to balance it, I should write 4 here and 2 here, 2Na2O. So oxygen is getting added. So you can explain everything here, all the other points. So here oxygen is being added, so sodium is getting oxidized. Okay, yeah, so how here, so we can't say here there is any removal of hydrogen. For that we need to take another example, but removal of electrons. So what is happening here, when sodium forms sodium oxide, then sodium loses electron. Na forms Na plus ion plus electron, and this electron is accepted by oxygen. So 4 such sodium atoms will make 4 sodium ion, and they will lose 4 electrons, and these 4 electrons are accepted by 2 oxygen atoms, and they will form 2 O double minus ions, right? So here you can see that sodium is losing electrons, or there is a removal of electron for sodium from sodium atom. So you can say that this third definition is also getting true here, that removal of electrons is also a oxidation process. Okay, so if you will add these two, you will get the same total reaction we have written here. So sodium is losing electron, or sodium is uh, getting oxidized by addition of oxygen. Similarly, you can see the fourth point here, increase of positive valency. How positive valency is increasing? So initial valency of oxygen was 0 here, because there is elemental form, it is not bonded to any other element. But in this Na2O here, as you can see, after losing one electron, sodium will have a valency of +1. So here there is an increase of positive valency. So this is also a case of increase of positive valency. So this is oxidation. So here sodium is getting oxidized. And last thing is oxidation number increase. So in the same way here, actually the sodium metal has 0 oxidation state, and positive valency +1, that will be the oxidation state, same as the positive valency. So again oxidation number is increasing, so you will say that oxidation is taking place here. Okay, great. So let's understand the reduction process in the same way. So let's take example of hydrogen gas plus chlorine gas, and they form together 2HCl gas. Okay, so here chlorine, what is happening with chlorine, that we will observe. And one more thing, oxidation or reduction processes don't take place separately. In the same reaction, oxidation and reduction both happen together. So like in the first example we have just seen, 4Na plus O2 is equal to 2Na2O, we say that sodium is getting oxidized. Then in the same way, oxygen here is getting reduced. So oxygen gets reduced and sodium is getting oxidized. All the other definitions you can check with oxygen, like oxygen is accepting electron here, oxygen's negative valency is increasing. So all these characteristics are of the reduction process. Okay, in the same this process we are going to talk about the chlorine, what is happening with the chlorine. So here there is a bond formation between H and Cl. So you can see that here addition of hydrogen is happening with chlorine. So you will say that chlorine is getting reduced. So addition of hydrogen is reduction. So you can say that chlorine is getting reduced here. Again here in Cl2 the valency of chlorine is 0, and in HCl if you will calculate the valency of chlorine, so it will be -1. So there is a increase in negative valency. So this is also a characteristic of reduction process. And similarly, if you will calculate the oxidation state, chlorine oxidation state in Cl2 will be 0 and -1 in HCl. So again there is a decrease in oxidation number, so it also verifies that it is a reduction process. And what were other definition? Addition of electron. Okay, so I will not say here complete addition of electron because this is a covalent kind of bond, so there is no complete transfer of electron. But if you know about the polar covalent bond, the bond between H and Cl, that is polar covalent, and because the electronegativity of chlorine is much higher as compared to hydrogen, so the shared pair which should exist between exactly in the midway between these two atoms, but that doesn't happen because chlorine electronegativity is higher, so it pulls the electron pair, and then electron pairs get shifted towards the chlorine atom of the bond pair. Okay, so because of this partial negative charge appears on the chlorine atom and partial positive charge on the H plus atom. So kind of partial pulling of electron is happening by chlorine, so this also verifies the reduction process. So I hope you understood these two very important concepts, oxidation and reduction. And if you have any doubt, please comment in the comment section, and like my videos and support me by subscribing my channel. Thank you very much. Take care and bye bye.